Okay, welcome to part 2, where we're going to look at solving simultaneous equations by substitution. Okay, actually just let me get another page up. Okay, so it's slightly different. Y equals x plus 4 is one equation, and x plus y equals 10 another equation. Let's call again them equation 1 and equation 2. Now the way these equations have been written are slightly different to how they were in the last video. I could rearrange them. I could make it minus x plus y equals 4 and x plus y equals 10, and then use elimination as my method. But I'm not going to do that. Because what we've got here is we've got at least one of the equations with one of the variables as the subject of the equation. So in equation 1, y is the subject of that equation. So what I'm going to do is I'm going to sub equation 1 into equation 2. And all I'm doing is I'm saying I know what y is in terms of x. So I know that this is y. So I'm going to rewrite the second equation as x plus 4. Because I know that this x plus 4 here is y. Okay, so I'm just swapping it out. And now I've got a simple linear equation to solve. That's going to be 2x plus 4 equals 10. 2x equals 6, and so x equals 3. Now, don't forget, you still need to find y, so that's back to the same process as elimination now. We're going to sub into equation 1, I think would be the easiest. We say y is equal to 3 plus 4, y is equal to 7. Okay, so a very, very slightly different approach. Let's just do another example. Let's just get rid of this. Okay, let's pick one. Let's go for the last one. Y equals 2x minus 5. And 7x minus 2y equals 16, was it? Yeah, equals 16. Okay? So again, this is perfect for substitution because the first equation has y as the subject. So again, I'm going to sub 1 into 2. So this time I know that y is 2x minus 5. So I'm going to swap this y for 2x minus 5. It's very, very important that you use a bracket. Okay, so we're going to rewrite equation 2 as 7x minus 2 lots of 2x minus 5 equals 16. Okay, and again, now we have a nice straightforward linear equation to solve. So I'm going to get 7x, just expanding the bracket now, minus 4x plus 10 equals 16. So 3x plus 10 equals 16. 3x equals 6. X equals 2. Okay, and then don't forget to find y. I'm going to sub into 1. We're going to end up with y is equal to 2 times 2 minus 5. So y is equal to negative 1. And don't forget that you can check whether your answer is right. Let's have a look here. We're going to substitute into equation 2. So we did 7 times 2 minus 2 times minus 1 equals 16. Now, is that true? 14 minus negative 2 equals 16, and that is true. 16 equals 16. So by subbing in, I check my work and I know that I'm right. Okay? So please do the checks. Let's skip past these. Let's go straight for these questions here. Okay, so stop your video and have a go. Okay? Hope we've done that. Here are the answers. Okay, so we've got some ones with some fractional answers. Okay, stop your video and have a go at these. What's neat about this is one of these actually is impossible to find the answer. Okay, there is no solution. There is no solution to the simultaneous equation. So see if you can find out which one. So stop the video and have a go. Okay. It's actually this one that was wrong, C. There is no solution to C. Okay, and the others did have a nice solution. Okay. Now, let's just try and understand a little bit why this one has no solution. I could rearrange the second equation to y equals x minus 9. So I've got y equals x plus 1 and y equals x minus 9. Now, if I plotted them on a graph, and I'm only doing a little rough sketch here, what you'll notice is, remember, y equals mx plus c, where m is the gradient. They have the same gradient. So one will look like this, and the other one will look like this. It's just the y-intercept that is different. They're actually parallel to each other. And so you can see on the graph that if they're parallel, they will never intersect. So there is no solution. Okay? So parallel lines will never intersect. They have no solution. Okay, let's just skip past some of these. Now, I'm not going to spend too much detail on this one, but obviously what I've been talking about is you can also solve these through graphing. Okay, so you can just pop these in your calculator, and if you want to find the solution to these simultaneous equations, well, I have them plotted here. It's at the intersect. So the solution is going to be when x is equal to 5, y is equal to 8. Okay. Now, you've just got to be careful. You might get something like this. If you're going to plot these in your calculator, you need to make sure y is the subject for each one. So in your calculator, you'll do y is equal to 8 minus x, and y is equal to 4x minus 7. Plot them and look for the intersection. So the solution is when x equals 3, y equals 5. That should be easy. Okay. Right, now we're going to do one more question that's tricky. Okay? This time what we have is a linear and a non-linear equation, and I need to find out what the value of x and the value of y is. Now, for the questions before, you could use either substitution or elimination to work out the answer. But for this one, you can only use substitution, okay? And the first thing you'll notice is that x or y are not the subject of either equation. So I'm going to have to change equation 1, and I'm going to rewrite equation 1 as x equals 7 minus 2y. So now I know that x is the subject. I can look to substitute in, okay? So I'm going to sub equation 1 into equation 2. And look what will happen. I'm changing x. This x is now 7 minus 2y. So I'm going to take 7 minus 2y squared. Use a bracket, please. Okay, plus 2 lots of x. So that's 2 lots of 7 minus 2y. Again, wherever there is x, replace it with what I know x to be, 7 minus 2y. Okay, plus y squared plus 2y equals 23. Now I have a quadratic equation in y, and it's pretty nasty, I have to say. But let's try and do it. Okay, so the first things we're going to do is expand all of these brackets. Don't forget that 7 minus 2y squared means 7 minus 2y times 7 minus 2y. So that's going to be 49 minus 28y plus 4y squared. Okay, now on to the next one. Plus 14 minus 14y plus y squared plus 2y equals 23. Okay, let's collect together y squared. Well, I've got 4y squared plus a y squared. That's 5y squared. Okay. Now let's collect together y's. I've got minus 28y minus 14y is negative 42y plus 2y is negative 40y. And now, remember, I need to have everything on the left-hand side because we need to make the right-hand side equal to 0 if I'm going to solve the quadratic equation. So 49 plus 14 is, that would be what, 63, minus the 23 that comes from the other side is going to be 40. Plus 40 equals 0. Now, I hope I've done that right. Okay, let's just check it. 49 plus 14 is 63, minus 23 is 40. Let's just check the y's. Minus 28y minus 14y is negative 42y, plus 2y, negative 40y. Okay. Now what we need to do is solve this equation. Now, there are a few ways that I taught you to solve it. One is factorization. Another is the formula. Another is graphing. And another is just using the equation solver in your calculator. Okay? And actually, do you know what I'm going to do? Just for the purposes of speed, I'm just going to use the equation solver in my calculator. So see if you can see how to do that. Polynomial f2 of degree 2, a is equal to 5, y is equal to b is equal to negative 40, c is equal to positive 40. Okay, we get some pretty nasty numbers actually, so I'm wondering whether I've actually made a mistake. Maybe I have. I actually get two results. It's a quadratic, so I should get two results. X equals 6.83 to three significant figures, or X, sorry, that's completely wrong, isn't it? Because that's Y and Y, not X and X. So Y2 should be 1.17 to three significant figures. And now what we need to do is just use this equation to work out what my x values will be. So x1 is equal to 7 minus 2 times 6.83, or x2 equals 7 minus 2 times 1.17. So there are two solutions. There are two solutions to this simultaneous equation, okay? I'm not going to bother to actually work out what they are, but if you think about it, it makes sense. Actually, do you know what? This is actually a circle. This would look like a circle, and this is a straight line. So you're getting one coordinate there and one coordinate there where they intersect. That's why you're getting two x's and two y's as your answer, okay? So I'm not going to have you practice this in the intro video. There is a My iMath assignment that will help you practice this concept. Again, if you don't understand anything, not an issue.